In this video, I will be modeling how to set up the answers in your summative assessment so that you can get the highest score on the 3 performance indicators that are being used to grade this summative. So one of the performance indicators is StructurePattern. If you have done the associated proof of the theorems, 50% of what you need to do is to earn that performance indicator of StructurePattern 9.1 is to simply write down the name of the theorem you would use to solve the problem. So for this, I have a 30-degree angle, which means this is a 60-degree angle, and that's a 90-degree angle. So this is a 30, 60, 90 triangle, and we're using the theorem that goes with that. So the 30, 60, 90 triangle theorem. You are halfway to having that performance indicator simply by writing that down if you also have the theorem's proof in your notes. We did do that in class. So the next performance indicator you need to have is the PredictModel. And PredictModel means to label the sides of the model that we have using the theorem that you are trying to implement to show how you could use the model to predict the answer. So I have U's and V's in this model, and when we did this in class, we used the variable A to represent the length of the shortest side. So the length of my shortest side here is the variable V. I'm going to use A to represent the length of that shortest side. And since the theorem says that the hypotenuse will be twice the length of the shorter leg, and that the longer leg will be root 3 times the length of the shorter leg, we could represent the problem like so. And now I'm 50% of the way towards the PredictModel performance indicator. Now, to get either one of these performance indicators all the way to an answer, with a correct final answer, like what's the length of the shortest side, what's the length of the longer leg, what's the length of the hypotenuse. If I can find those 3 answers, even if I show it in a very messy way, but I've correctly got the answer and I didn't use precision in any kind of way, I can get both of these performance indicators. I just have to figure out how to get the correct final answer. For this model, I am going to demonstrate this using algebra because I want to also get the precision performance indicator, which requires using algebraic precision for solving the equations and getting the value of the variables. So the side that we knew something about was the longer leg. So I'm going to start with my longer leg, 9 equals a root 3. And I have this equation. If I can figure out what a is equal to, that's the length of my shorter leg, then I can solve the problem. So on this right side, I divided by root 3 so that I could get a by itself. Sorry, I made my line too long. And then on the other side, I'm also dividing by root 3, so 9 divided by the square root of 3. That is not the way we are allowed to write an answer. We can't write a square root in the denominator, so I'm going to have to do a little bit of math. You could do this part on scrap paper if you want. So I have my little post-it note available to represent my scrap paper. And we have 9 over the square root of 3 times root 3 over root 3. If I do that, that will cause the denominator to be a whole number, 3, and the numerator to be 9 root 3. Now, I'm not quite done yet. Now that I have rewritten it without the square root in the denominator, I still need to simplify the fractional part that's not in the square root. 9 divided by 3 is simply 3. So 3 root 3 is equal to what we started with. If you want to write this neatly on your paper, you can. If you're trying to get precision, just make sure that it doesn't interfere with anything else and that it's organized in some kind of way. And so now we have 3 root 3 is equal to A. To find the lengths of the other two sides, I have A is equal to V and U is equal to 2A. Notice both of these have an A, and we now know what the variable A is equal to. So I can substitute 3 root 3 in here, and I get the value of V, which is one of the sides that I need to find, the length of the shorter side. And I can substitute in 3 root 3 over here, and I will get U equals 2 times 3 root 3, which means that U is actually equal to 6 times the square root of 3. And now I have the length of the hypotenuse as well. And I have shown the work using precision. I see that I have plenty of space on here to put my scrap work, so I might label this scrap. You didn't have to label it scrap. And then just neatly write in the work that I did. To show where that answer came from. Okay, this is one way that you could model your work. I've met the first performance indicator, that their structure pattern has been identified. This is the method that we're using to solve the problem. I have used a model to try and predict the answer, and my model goes along with the theorem. These match each other. And then I've set up algebraic equations to demonstrate how to use algebraic precision in order to get the answers. And I even took it one step further and showed my optional scrap work of some math calculations, how to get from here to here. If you do show me the scrap work, then if you made a mistake in that area, I'll be able to tell you what it is you're doing wrong, so you'll know why your answers are incorrect if you do get them incorrect. Okay, hopefully it is clear how to get the performance indicators. I'm just going to model a couple more problems, and that's it for this video. So here we already have the length of this side. Notice that I have A already in the triangle, so that means I cannot use A as my variable. Good thing there's other letters in the alphabet. So I'm actually going to call this shorter side X, and my longer leg would then be X root 3, and my hypotenuse would be 2x, and I am still using the 30, 60, 90 triangle theorem. In this case, I already know the length of my shorter side, so I'm going to just start by writing that information down. And now I can quickly substitute this information into the other two equations. First, I write the equation down, and then I show the substitution. So instead of x, I have 5 divided by 2. To multiply a whole number by a fraction, remember that this 2 is over a denominator of 1. So this is really 2 times 5, which is 10 divided by 2. And 10 divided by 2 is really 5. There's other ways to do that problem to get the answer of 5, but that is one way. Over here, I need to substitute in 5 halves and multiply that by root 3 in order to get the length of the longer leg, which is x root 3. 5 times root 3. Well, the root 3 is actually over a denominator of 1. And to multiply fractions, we just multiply the numerator, 5 root 3, over the denominator, 2 times 1, which is just 2. And so now I have the length of my longer leg. So notice the math looks very different, but there are still some general similarities between the two problems. We're going to do just one more in this video. So down here, I have again oops, I forgot to put in my angle measure here. We have a 30, 60, 90 right triangle. Remember, across from the 60-degree angle is the longer leg. And here again, I have an A, so I'm going to have to use X. This is going to be X root 3, because that's my longer leg. And then this B here is I'm going to use X for my model. And for A, I'm going to use 2X, because that's my hypotenuse. And again, I'm using the 30, 60, 90 triangle theorem. My work is sort of going down here, so I just want to make it clear what work goes with what. And I don't know the length of the shorter side. In this case, I know the length of the longer leg. So I'm going to just set up my equation. 5 root 3 equals X root 3. Those of you doing mental math might be like, oh, but this has a root 3 in it, so that means X is 5. Well, you would be correct. To show that with algebra, we just divide both sides by root 3. This root 3 cancels out, and root 3 divided by 3 here, root 3 here is also 1. These were both 1. So X times 1 is just X, and 5 times 1 is just 5. And so that's algebraically how we can show that the value of X is 5. We have X in all 3 of these locations. So now I can find the length of the shorter leg. B is equal to X, so that means B is equal to 5. And the longer leg, 2X is equal to the hypotenuse. And so we are going to substitute in the 5 where the X was. And we'll know that our hypotenuse is equal to 10. I hope this information was helpful.